Hello friends, in today's question, on the stationary block of mass 2 kg, a horizontal force F starts acting at t equals 0, whose variation with time as shown in the figure. The coefficient of friction between the block and the ground is 0.5. Now answer the following questions. First, find the time when acceleration of the block is 0. Find the velocity of the block when the first time its acceleration becomes 0. And third is find the velocity of the block at time 12 seconds. So this is the block 2 kg, friction coefficient is 0.5, force F is being applied from left to right. This is a graph between the force and the time, and we are going to answer all these three based on these two figures. So let's first of all draw the free body diagram for the block 2 kg and find out the frictional force. So this is our 2 kg. The downward direction, it will be 2g, and the force is being applied in this direction. So we are going to have Fr opposite to it, and there will be a normal, let us call that as N2. So you can say that our Fr max, which is limiting value of the friction, will be given as coefficient mu multiplied by N2. Mu is given as 0.5, and this will be 2 multiplied by 10. So we get the maximum value of the friction will be equal to 10 Newton. And let's for the part A. Here we have to find out the time when the acceleration of the block is 0. So we can say the acceleration of the block will be 0 when the applied force F is less than the maximum value or limiting value of friction. Okay. When will be 0 when applied force F is less than equal to Fr max. Okay. Or we can say F is less than equal to 10 Newton. So from the graph, you can clearly see that the force is 10 Newton at 5 seconds. And if you extend this graph, let me draw it here. So this is time and this is force in newtons. And we have graph which is something like this. It crosses here at 10 seconds. This is time in seconds, and we are given this will be 10 Newton and this point is 20. Correspondingly time is given as 5 and here it is given as 15. So the applied force should be less than equal to 10. Okay. So this is the value of the applied force F, and it is having the value of 10 at 5, and if you extend this, it is also having these three values. Okay. But from here we can say that at time t is equal to 10 seconds, the value of the applied force is going to be negative. Okay, and this is given as minus 10. Therefore, the value of time for which the force will be less than equal to 10 will be between 5 and 10 seconds. Therefore, the time for which F is less than or equal to 10 Newton is between 5 seconds and 10 seconds. In simpler terms, we can say t less than or equal to 5 is less than or equal to 10. This, the acceleration will be equal to 0. And now let us solve the part B. Part B, we say let the acceleration of block is A. Let the acceleration of the block is A. 2 kg, force F, frictional force F R, and it is moving in this direction with acceleration A. So we can write the equation of the motion as, therefore, F minus Fr, which will be equal to Fr max because it is already in motion, will be equal to mass into A. And from here we can find out the value of the acceleration. So we can say that the value of force is equal to Fr plus Ma. Now let us find out the equation for the line based on this. The equation for the line is given as y is equal to mx plus c, and here y is f, here y axis is represented by f and x axis is represented by time t. So therefore we can say y axis is force and x axis is time. Therefore we can write this equation as F is equal to mt plus c. Now let us find out the value of c. So you can say for t is equal to 0, the value is given as 20 Newton. Okay. You can say for t is equal to 0, F is equal to 20 Newton, which implies that c is equal to 20. So let me substitute here. We can write this as now F is equal to mt plus 20, and at time t 10 seconds force becomes 0. You can say for t is equal to 10 seconds, F is equal to 0. So let me substitute it. So we get F0 is equal to m multiplied by 10 plus 20. From here we can say that m is equal to minus of 2. therefore the equation of the line will be given as f is equal to minus 2t plus 20. Or it can be also written as f is equal to 20 minus 2t. Therefore, if the a is acceleration, which we already said that a is acceleration, thus for acceleration a, we can write this as ma is equal to 20 minus 2t. From here, you can say that a is equal to 20 minus 2t divided by mass is given as 2 kg. So we get the equation as mass is given as 2 kg. So we get this equation as a is equal to I think I made a mistake in solving this. Let me do it again. The equation for the acceleration, let us call this as equation number 1. So we can say from equation 1 we get acceleration is equal to f minus fr divided by m, and f we already know is 20 minus 2t. We substituted here, so we get acceleration is equal to f is 20 minus 2t and fr is our 10, mass is given as 2. So we get acceleration is equal to, this will be our 10 minus t minus 5. So we get the acceleration equation as 5 minus t. Okay. Now we are supposed to find the velocity of the block when for the first time its acceleration become equal to 0. Okay. So let's find out the velocity. For velocity v is equal to integration of a integration of 5 minus t, and this is from 0 to 5 dt, and we get velocity is equal to, this will be 5t minus t square by 2 and 0 to 5. So this will be coming as 25 minus 25 by 2, which will be equal to 25 by 2. So velocity we get as 12.5 meter per second square. Okay. And for the next part, we are going to find the velocity of the block at t is equal to 12 seconds. You can say for part B, part C, velocity of the block at t is equal to 12 seconds. Velocity of the block at t is equal to 12 seconds. Okay. From the graph, you can clearly see that for the time t greater than 10 seconds, it's basically retarding motion because the force become negative. Okay. You can say for time t greater than 10 seconds, it is a retarding motion. Because of that retarding motion, we can also say that the value of friction is greater than the applied force. So it means Fr max is greater than F. Okay. So once again, so this is about 2 kg, applied force is F, and this is now Fr, and suppose it is moving with the retarding motion of A. Therefore, we can write this equation as Fr minus F is equal to mass into acceleration A. Okay. Now, once again, we are going to find out the equation from solving this part. Fr, we already know, is Fr max, which is 10. So we can say our Ma is equal to 10, rather mu n minus F, which is equal to 10, and equation for F is given as equation number 1, which is 20 minus 2t. 20 minus 2t. Sorry, not equation 1. Okay. This equation, let me write this as equation 2, where F is equal to 20 minus 2t from equation 2. So we can say that acceleration A will be equal to, this will be 10 minus 20 plus 2t divided by 2. Acceleration will be equal to, this will be minus 10 minus of 5 and plus t. So, as it is a retarding motion, therefore the final velocity will be equal to 0. So we can say, as the block is having retardation, therefore its final velocity will be 0. So we are going to find out the time at which this final velocity will be 0. Okay. Therefore, we find out the time, let us suppose that is given as t, at which final velocity becomes 0. So we know already the equation for acceleration. That will be equation number 3. So we can say from equation 3, A is equal to minus 5 plus t. We can write that velocity and its final is 0, and initial we already found out is 12.5 is equal to minus 5 plus t, and dt time is 5 seconds, and this time is t. Okay, from here we can clearly say that at time 5 seconds velocity is 12.5 meter per second square per second, sorry, and at time t second velocity is 0. So we are going to find out this time. So we integrate it, we get this as 0 minus 12.5 is equal to minus 5t, and this will be plus t squared divided by 2, and this will be 5t. So we solve it, this will be minus 12.5 is equal to minus 5t plus t square upon 2 minus, this will be minus of 25, and this will be plus 25 upon 2. So we get this as minus of 5t plus t square upon 2 minus, this will be 50, 50 and 25, so this will be minus of 25 upon 2. We solve it, this becomes as 25 multiplied by 2 is equal to, this will be minus of 10t plus t square and plus 25. One second. Okay. So there was mistake from my part here, as it is a retarding motion, so the acceleration will be with having a negative sign. Okay. So from here I can say that my acceleration retardation will be this equal to minus, this will be my 5 minus t. So this is our equation number 3. So this will become plus, this will become minus, and this will be plus, similarly this is minus, and we get this as plus, and this is minus, and let me sort it out here also, this will be plus and this will be minus, accordingly this will be plus and this will be minus. Okay, apologies for that. So here I can write that this equation is 5 minus t, okay, and this will be coming as plus. Okay, so because of the plus, this will be minus and this will be also minus. Now hopefully everything is correct. This is plus, minus, minus, this is minus, this is minus, this and this goes away, so we can say our equation can be t square plus 10t this will be plus and this become plus, and what else, so we can write this as 10t minus t square is equal to 0. Yeah, that's correct. I'm sorry for that. Okay, so we get this as t, 10 minus t is equal to 0. So from here we can say t is equal to 10 seconds. So it means at t is equal to 10 seconds, the final velocity will be 0. Say for, or rather we can say from t is equal to 10 seconds, the final velocity of the block will be equal to 0. Okay. Now if the final velocity is 0, so you can say therefore at time t is equal to 12 seconds, the final velocity, the velocity of the block is 0. Okay, so this completes the question. So please, I think I corrected all the things because of the retardation. This is because of the retardation. Okay. So this becomes a phi minus t. Thank you, and sorry for the mistake.